Now, in this revision video, we're going to learn about the electromagnetic spectrum. The electromagnetic spectrum is made up of 7 different types of electromagnetic radiation. Another way of looking at it is to say it's the range of all possible frequencies of electromagnetic waves. Now, what is an electromagnetic wave? An electromagnetic wave is simply a wave that carries energy, and they have a couple of other special properties too. They all travel at the speed of light, 300,000 meters per second, and they are all transverse waves. That means that the direction of vibration is at 90 degrees to the direction that the wave is travelling in. Now, we're going to look at these 7 types of waves, but first of all we're going to look at how the electromagnetic spectrum was discovered, because it's really important that we know the 2 key experiments for its discovery. The first experiment comes from a man called William Herschel in 1800. William Herschel used thermometers to measure the temperature of light, and he found out that when he split light with a prism and measured the different colours of light, the different colours came up at different temperatures, red being the hottest one. Herschel was fascinated by this, and so decided to play around with his experiment a bit more. He got a thermometer and put it just past where he could see the red light. So he couldn't see anything was there, but he thought there might be something. So he put the thermometer just past the red light and found that actually it had the highest temperature, even higher than red light. So if red light was 28 degrees, where he had placed his thermometer just beyond the red light would have been 30 degrees. Now, Herschel was baffled by this because this shouldn't happen. There was nothing there that he could see. So really it should have just been room temperature when his thermometer wasn't in the light. But Herschel interpreted this discovery as meaning there must be some sort of light that he could not see beyond the red, and he named this infrared. Now, a year later, a man called Johann Ritter, a German scientist this time, was doing similar experiments. He had heard about Herschel's work and was fascinated by this and wanted to find out if there was other types of light that we could not see. Ritter used a chemical called silver chloride, which when exposed to light turns black, and it turns black at different speeds depending on the colour of light. So actually it turns black slowest in red and turns black quickest in violet light. Now Ritter wondered if there was some sort of light that he couldn't see beyond the violet light, and so he placed the chemical under invisible light just beyond the violet that he couldn't see, and it went black even quicker. And so this new type of light, this invisible light beyond the violet, was named ultraviolet. Now, there are some important patterns we need to know in the electromagnetic spectrum. Firstly, you need to know the order of the electromagnetic spectrum. So you need to know that it goes from radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. You need to know that order. A good way of remembering that is RMI Vox sheet. Although it sounds silly, you'll actually remember that after a few times of trying to memorize it, and that really helps you to remember the order. Once you've remembered the order, you need to know that as we go along the spectrum, the wavelength of the electromagnetic waves decreases and the frequency increases. That's important to know, but it's important to know because of the effect that that has. You see, as we go along the spectrum and the frequency increases, the amount of energy that the wave has increases as well. So radio waves carry very little energy, but gamma rays carry an awful lot of energy. And this is because radio waves have a very low frequency and gamma rays have a very high frequency, so transfer energy a lot quicker than radio waves do. Now, another thing to know about is the fact that as the amount of energy being transferred increases, the danger increases as well. So radio waves are not harmful in any way, but gamma rays really are. Gamma rays are very dangerous, as we'll see later on. So we're going to have a look now at each wave and look at how harmful it is and the uses of them. Firstly, radio waves. Radio waves are used in satellite transmissions, so communicating from one satellite to the other for different types of applications, maybe for the military or for other types of communications. They're also used for commercial broadcasting as well, so you get to listen to Radio 1 or BBC Radio 2 by radio waves going from a radio mast where they are transmitted to the radio in your house. Radio waves are not harmful to human life at all, so we're surrounded by them day to day and they don't hurt us in the slightest. Microwaves, if we move one step along the electromagnetic spectrum, are slightly different. Microwaves are used in mobile phones, so they're the waves that pass between our mobile phones when we call or text someone. They're also used in microwave ovens. Now it's important that you have an appreciation of how a microwave oven works. It emits microwaves, and the microwaves are absorbed by water and fat in the food. And the energy in the wave becomes heat, that then heats up the food and cooks it. Now this is great because it means that you can cook a potato in a few minutes, but actually microwaves can be very harmful, and they can be harmful to life, to us. They can cause internal heating of our body's cells. Now mobile phones don't harm us, or so there's no research to conclusively prove that they harm us yet. One reason for this is that the intensity of the microwaves coming from a mobile phone is much smaller. Much less energy is transferred to you when a microwave from a mobile phone passes through it than if you put your hand inside a microwave oven. Much more energy would be transferred to you then, so it would be much more intense. Now, the next one is infrared. Infrared is used in several different things, but key things are toasters and also remote controls. And infrared again is harmful and becoming slightly more so than microwaves. Infrared can cause skin burns when you're exposed to large amounts of infrared light. Now, a remote control can't hurt you, but if you put your hand inside a toaster, it really could. And this again is because of this idea of intensity. The infrared rays coming from a remote control are less intense than those that have been emitted inside a toaster. Part of this is due to the fact that when you press a button on the remote control, it emits infrared rays for a fraction of a second, whereas a toaster will be on maybe for 3, 4, even 5 minutes at a time. And so you're getting a lot more energy transferred to you. Now, the next one is visible light. And visible light, you don't need to know a use of it or how harmful it is, but you do need to know a couple of facts about it. You need to know that it is the only part of the electromagnetic spectrum that we can see. And that if we got a prism, we could split it up into the different colours that we see in a rainbow, going from red right through to violet. And that range of colours is called the visible spectrum. Once we pass visible light, we get to ultraviolet light. So this is the type of light that Ritter discovered in his experiments. Now, ultraviolet light can be very harmful. It's the type of light that can lead to cell damage and can lead to skin cancer. And so it's the type of light that will come from the sun and will give you a tan when you're on holiday, but also if you stay out in it too long will burn you and can lead to these damaged cells and to skin cancer as well. Ultraviolet light is used in tanning beds for getting a fake suntan, and it's also used to sterilise hospital equipment as well. So ultraviolet light is beamed intensely onto used hospital equipment, and the idea is that it will kill off any microbes that are on the equipment. Okay, so we're getting to the more harmful ones now. X-rays. X-rays, as you all know, can be used for X-ray photographs. X-rays are blocked by bones. They can't go through bones, but they will pass through flesh. And so when you have an X-ray done at a hospital, a source of emitting X-rays is placed behind you and a camera is placed in front of you. The X-rays pass through your skin and get to the camera, but they don't pass through your bones, they're blocked. And so you're left with like a silhouette, like if you put your hand in front of a light, of your bones. And that's how an X-ray photograph works. You need to know the basic idea behind that. X-rays can be very harmful, however. They can cause mutation or damage to cells, and this in turn can actually lead to cancer as well. Our final electromagnetic wave is gamma rays. Gamma rays are also extremely harmful, and again, like X-rays, but with even more energy and even more intensity, they can cause cell mutation, which leads to cancer. Interestingly though, gamma rays can also be used to treat cancer, which is quite bizarre if you think about it, but they can be used to treat cancer as well as causing it. In order to treat cancer with gamma rays, the gamma rays are targeted at cancerous cells, and they're absorbed by the cancerous cells. And with all that energy going into the cancerous cells are destroyed. This happens with relatively little damage to the rest of the tissue around cells, and can be very successful at treating cancer. So, we've gone through the electromagnetic spectrum and the things you need to remember. You need to remember what an electromagnetic wave is. You need to remember the order of the 7 different types of wave in the spectrum. You need to remember the 2 scientists, Herschel and Ritter, and their experiments and their discoveries that led to our understanding of the electromagnetic spectrum. You also need to know the patterns in the electromagnetic spectrum, that as the frequency increases, the energy increases, and so potentially the danger of the waves increases as well. And you need to know at least one use and how harmful each wave can be. Good luck.